this method as phenol coefficient test. So before go ahead with phenol coefficient test, there is a small part of agar test method that was left to discuss. Method. Another variable of this method is known as couplet method. So instead of adding previously loaded paper discs, we simply make a cavity or cup in the agar gel, agar bed. So similar to previous method, this is the inoculated agar in which microorganisms have already been added. And in this, we are making a cavity or a cup with the help of a borer. Okay, and in this cavity or cup we are going to add known concentration and known amount of antibiotic, and after addition of that you can make as many cavities or as many cups in one agar plate. You can make 5 cups around this, just in the same way we had placed paper discs, and in all those cups we add known amounts of antibiotic or chemical disinfectant, and then these plates will be incubated. Similar to paper disc method, you will be observing zones of inhibitions around these cups or cavities, and by measuring the diameters of zones of inhibition you will be able to determine the efficiency of the killing efficiency of the antimicrobial agent. So in this test, larger the zone of inhibition is the organism. The smaller the zone of inhibition, the organism is said to be resistant to that antibiotic. So in early methods, we determine the concentration, or we determine, we measure the zones of inhibition, we check for turbidity, we check clarity, and all these parameters we checked to determine at what concentration that chemical agent is effective in killing the organism. So in phenol coefficient test, we are going to determine the same thing but in different way. So we are simply going to compare the killing efficiency of test antimicrobial agent with a standard, and standard is here phenol. So phenol is a broad spectrum antimicrobial agent. So phenol almost kills everything, every kind of bacteria, fungi. So phenol is very effective in killing, and that is why it is at low concentration. It is used as a static agent. At high concentration, you can also use it as a sterile agent. So that is why phenol is now considered as standard antimicrobial agent, and other agents are compared with phenol to test their efficiency. What they have written here standardizes the potency of bactericidal agent in comparison with phenol using specific test microorganism. Okay, so you can see there are 4 tests written enlisted here on this slide. So what are these tests? First one is RW test. It is radial Walker test. Second one is AOAC, or Association of Official Agricultural Chemists test. Third one is FDA test, and the last one is CM test, also known as Martin test. So all these tests are phenol coefficient tests only. Only thing is, these tests are performed in different ways, but basic principle, basic mechanism remains the same. All these 4 tests are 4 variables of phenol coefficient test. So let's just understand first what is the basic procedure and what is the basic mechanism behind this principle, behind this coefficient test. Okay. So the procedure step. So as we already have known, standardizes the potency of bactericidal agent using specific microorganism. So first step, a series of dilutions of phenol and experimental antimicrobial agent are prepared in sterile tubes. Viable test bacteria, for example, Staph aureus or Salmonella typhi, are inoculated into each tube and incubated at 31 degrees Celsius. After 10 minutes, depending on the method or time variable, samples of inoculated tube are transferred into fresh culture medium with the last step will be the broth culture tubes are evaluated for growth by turbidity. So let's understand how this test is performed. So on the next slide, you can see there are two sets of test tubes. So as we already know, we have to compare the efficiency of test antimicrobial agent. Here, for example, we will consider test antimicrobial agent is Lysol. Okay, so you have to test efficiency of Lysol in comparison with phenol. Which one is more efficient? Okay, and determine the phenol coefficient. So the first set is for Lysol. So what we have added in that, it is simply nutrient media in which we are adding nutrient broth, for example, in which we are adding increasing concentration of Lysol. Sorry, a decreasing concentration of Lysol. Okay, so we are making dilutions of Lysol. So first dilution is 1:50. That is the most concentrated one. So from 1:50, we have prepared other dilutions from 1:50 goes 1:100, 1:150, 1:200, and 1:250. Okay. So the concentration here is going on decreasing from 1:50 to 1:250 because we are diluting, we are making dilutions. And so in nutrient media, in nutrient broth, we have added Lysol in first test tube, then we have made dilution in further test tubes in nutrient media, and in all these test tubes we have added equal amount of microorganism. So we have inoculated these test tubes with equal amount of microorganism. Okay, so that was about the set of Lysol. Now what same thing we have done for phenol. So nutrient media, nutrient broth, in which we have added first concentration of phenol, that is 1:50, and made further dilutions 1:60, 1:70, 1:80, and 1:90. And again, in all these test tubes we have inoculated these test tubes with equal amount of microorganism. Okay, so what are we going to do? We are going to let Lysol and phenol react with these organisms in these test tubes for the period of 5 minutes. Okay, so time period is very important here. After 5 minutes, what we are going to do, we are going to simply take the samples from each test tube and inoculate those samples in a fresh nutrient media. So you have to remove the samples from these test tubes and add in the new media, new fresh media, and those test tubes you will have to incubate for growth of organism. Okay, so this was the first set. Why am I calling this as a first set? Because we reacted this for a period of 5 minutes. Similarly, you have to repeat this for next time point, that is going to be 10 minutes. So prepare the whole set again for Lysol and for phenol as the method as but let it react for a period of 10 minutes. After 10 minutes, again take sample from each tube and inoculate with fresh media and incubate. Similarly, repeat the test for the period of 15 minutes. So we have done the same thing for three different time periods: 5 minutes, 10 minutes, and 15 minutes. Okay, so all these test tubes we are going to incubate for letting organisms grow. Okay, so what does your logic say? We are making dilutions here. So first test tube or both the sets is contains highest concentration of the Lysol here and phenol here. Okay, so there will be no growth because the concentration is very high. This much concentration will kill the organisms. Organisms will not be able to grow at these concentrations. So most probably there will be no growth observed after incubation at these concentrations. On the second test tubes, the concentration is decreasing because we are diluting it. Okay. These organisms will be able to grow for some to some extent. So again the same thing at this concentration, maybe if you let it react, okay, If you go on further, growth, the concentration is going to decrease. So phenol will go on increasing. Again, the time period will have its effect on it as well. If you are letting these tubes run for 5 minutes, maybe these lower concentrations in 5 minutes they won't be able to kill the organisms. But if you go on increasing the incubation time to 10 minutes and 15 minutes, maybe this low concentration, lowest concentration will be able to kill the organisms. So because of more time period, these lower concentration at high time period will be able to kill the organism. So we'll see all the results, but before that, let's learn what is the formula for determination of phenol coefficient. So phenol coefficient formula is highest dilution of test that destroys all organisms in 10 minutes exposure but not in 5 minutes divided by least dilution of phenol that destroys all organisms in 10 minutes but not in 5 minutes. But let's understand the meaning of the formula. So this is the observation table for all sets of test tubes that we just discussed. Observe 3 terms for 5 minutes, 10 minutes, and 15 minutes. So first one is disinfectant, and there are dilutions of disinfectant enlisted here. 1:50, 1:100, 1:150, and 1:200. And below that, there are dilutions of phenol enlisted. 1:50, 1:60, 1:70, and 1:80. So what does the formula say? Again, highest dilution of test that destroys all organisms. Test disinfectant, that is Lysol here, that destroys all organisms in 10 minutes but not in 5 minutes. So here, if we observe, 0 means no. So in 1:50 dilution, first concentration, all the organisms are killed. Okay, so second dilution is destroying all the organisms in 10 minutes. In 10 minutes, there is no growth. So it is destroying all the organisms in 10 minutes, but not in 5 minutes. So 5 minutes, there is some growth observed. So this disinfectant Lysol and this concentration is destroying all the organisms in 10 minutes, but not in 5 minutes. Okay, so this is the concentration of our interest. Similarly, determine the similar concentration for phenol. For phenol as well, the concentration that destroys the growth, all the organisms in 10 minutes, but not in 5 minutes. That is this one, 1:60. So as the formula says, divide this concentration by this concentration. So simply divide 100 by 60 and your answer is 1.66. So phenol coefficient for this disinfectant, for example, Lysol, is 1.66. Okay, so how do you interpret this phenol coefficient test? If the result or value of phenol coefficient is higher than 1, more than 1, that means the disinfectant here is more efficient than phenol. If this value is below 1, lesser than 1, then you say the test disinfectant is less efficient than phenol. And if the value is exactly 1, that means the test disinfectant is equally efficient as phenol. That is the interpretation of phenol coefficient test. Now, as we had seen earlier, there are 4 variables. There are 4 variables of the test, and we have also read the names of those variables. So observe why these variables are there, because this test is performed under different conditions. So what are the variables? It can be like volume of this nutrient broth can be meant. pH of this meter can be different. The temperature at which this test is carried out can be different. The type of organism that you add in this can be different. So all these variables constitute those different four tests. So what are the variables? Let's discuss. So the first one was radial Walker test, RW test. So in this, the medium pH is between 7.3 to 7.5. FDA test, slightly acidic 6.8. In Chick-Martin test, the pH is 7.3 to 7.5, and in AOAC it is again 6.8. You can ignore this crown agents last column. We are not considering this. So medium volume is also variable. In radial Walker, it is 5 ml. In other test, it is 10 ml. So reaction mixture volume is again different, and the diluent is different. The in Chick-Martin test, the diluent used is yeast suspension. In other tests, it is water. Reaction temperature is also different. For radial Walker, it is slightly lower, 7.5 degrees Celsius. The organism that we inoculate is S. typhi in all the test tubes, but in AOAC test, you can also use Staphylococcus aureus. Now, sampling time intervals is very important. So, sampling time intervals are different for all the tests. The example that we just discussed was about this test, FDA test or AOAC test, because in that we have considered three time points: 5 minutes, 10 minutes, and 15 minutes. So, time points are different for radial Walker test: 2.5, 5, 7.5, and 10. And for Chick-Martin, there is a single time point. So based on the time points, formula also varies. Formula for calculation of phenol coefficient also varies. So for radial Walker, the formula goes like this: dilution of test killing in 7.5 minutes, but not in 5 minutes, divided by same for phenol. For FDA and AOC, we have just discussed in previous example. For a CM test, Chick-Martin test, mean of highest phenol concentration inhibited and low permit growth divided by same for phenol. So at this time point, whatever is the concentration and the growth divided by same for phenol, there is only single point here. So there are advantages disadvantages for this phenol coefficient test. So advantages, it is a cheap test and quickly performed. So you don't need extraordinary chemicals or laboratory setup to perform this test. And disadvantages are only a single strain of microorganism can be tested against given organisms, again given antibiotic or antimicrobial agent. Test bactericide activity. It tests bactericide activity only at one concentration, at one temperature, and at fixed time. There can be sampling errors while performing this test, and many tests do not consider presence of organic matter and do not give tissue toxicity index. So these were the advantages and disadvantages of phenol coefficient test. So that was all about all three methods. First one was tube dilution assay, second one was agar diffusion method, and third one was phenol coefficient test. For phenol coefficient test, you will have to by heart the formula, you will have to by heart the example, you will have to by heart the entire table of variables for all four tests and advantages and disadvantages. Phenol coefficient test is very important for your exam. That's all. Thank you.